models, applications, word problems, these are all pretty synonymous in most algebra books. I grew up calling them word problems. Most people cringe when they hear that. Now, models and applications is more probably what the book's saying. You know what? The books might have said that 100 years ago when I took it as well, but it's just what I remember calling them as word problems because there are a lot of words in them, and I like numbers better than words. So let's look here at models, applications, and word problems. So to solve an application problem, first thing you do is read the problem carefully, and many books tell you to read it several times, okay? You just got to figure out what you're doing, okay? Identify the unknown and use a variable to represent that unknown. Now, many times you use X, but I like to play around and use other things, especially letters that make sense or something like that with it. So like if I'm talking about hours, I might use H or T for time, something like that. If possible, write any other unknowns in terms of the variable used in the step above. So if I call it T or H or X and I have another unknown, I want to do whatever I can to write it in terms of T or H or X. Okay? I don't want to introduce a new variable unless I have to. So, in this video, I'm going to stay pretty simple with that and not do some of the other ones that require more advanced techniques. Write an equation based on the words, the statements, the sentences that are given, however you want to say that, and then solve this equation and check your answer based on the words given, not the equation you wrote down, because if you write the wrong equation down, your answer might check out with your equation but not answer the question that was asked. So just go back and make sure it's logical and makes sense, okay? So this video only addresses linear applications. Again, something you can write in one variable, possibly an X and a Y and solve for, whatever, but we're probably not even going to do that. We're going to do it in X or H or T, and then everything else is going to be in terms of H or X or T for that problem. So let's look through some of these. So when 2 times a number, so we're going to start with straight, just write down an equation from the words and go from there, okay? So when 2 times a number is decreased by 3, the result is 11. What's the number? So let me tell you this just kind of in general in math. There are, if you see something in order, like 2 times a number is decreased by 3, it's going to go 2 times your number and then minus 3. There are 3 words that turn things around and change the order, okay? 3 words that change the order: to, from, or than. If you see to, from, or than, then you need to swap the things around. Whatever's first comes last, whatever's last comes first. Before and after the to and the from or the than. Okay? To, from, or than. Those are the 3 things that, so if you have, added to, or subtracted from, or more than, you would then change the order. If you see those 3 words, you change the order. Otherwise, it comes in the exact order it's in the words, in your algebraic expression, and then into your equation, okay? So here, 2 times a number. So I'm going to call my number n. You can call it x. You can even call it, y'all, nowadays that's hashtag, but when I grew up, that was number sign, okay? So anyway, n for number. I'm real original, right? So I could use G for guest or something else. But anyway, whatever you want to do. So when 2 times a number, so 2 times a number is 2n. If you write a number times a variable, that means multiply. 2n is decreased by 3. So if we take 2n and subtract 3, the result is 11. That should be is. Okay, the result is 11. Okay, and is means equals. All right. So the result is 11. All right. Not it. The result is 11. So then 2n minus 3 equals 11. So then I'm going to solve this. I'm going to add 3 to both sides. So 2n equals 14, divide by 2, and n equals 7. So it's not really that n equals 7. What is the number? The only answer here is 7. You could have called it x or n or hashtag number sign, G, Q, R, M, P, smiley face. You could have used whatever you wanted to. Okay? So the number there is 7. So the next one says one number exceeds another number by 7. The sum of the numbers is 25. Find the numbers. Now, here's the deal. You got 2 numbers here, but call one of them something. One number exceeds another number by 7. So one number, let's call it x this time, and it exceeds the other number by 7. So if one number is x, the other number does what? It's x. What does exceeds mean? It's plus. So then if one number is x, the other number is what? X plus 7, right? So you got an x and an x plus 7. So one number exceeds the other one. So if you have x, the one that exceeds it by 7 is x plus 7. So those are your two numbers, and it says the sum of the numbers is 25. So then the sum, x, and I'm going to emphasize this, plus the other numbers, x plus 7, is 25. Now, if you're just summing numbers, you don't have to put the parentheses around those. If it says 2 times this, or 2 times the sum, or 2 times, then you need, or 3 times it, or whatever, then you might need parentheses. But here, if you're just summing them, these parentheses here are all extra. So I really could have written this x plus 7 equals 25. So I'm going to put those together and get 2x plus 7 equals 25. I'm going to subtract 7, which I could have done on the last step. 2x equals what? 18. And then divide by 2. So then what does x equal here? 9. So find the numbers. 9, and if x is 9, this number is 9. This number is 9 plus 7, which is what? 16. So my two numbers are 9 and 16. Do they sum to be 25? That's a good way to check it. What is 9 plus 16? Bingo, it's 25. All right, so there you have it. 9 and 16 sum to give you 25, and one of them is 7 larger than the other, or exceeds the other one by 7. All right, the sum of 3 consecutive integers is 24. Find the 3 integers. What does it mean to be consecutive integers? Well, integers, remember, are positive and negative whole numbers and 0. Okay, so negative 8's an integer, 54's an integer, right? No decimals, no fractions, right? And they're 3 consecutive. That means they're in a row, like 1, 2, 3, or like negative 5, negative 4, negative 3. If you sum them, if you add them together, the sum of 3 consecutive integers is 24. So sometimes it may even help. I wrote it up to the side there earlier, but maybe you say, okay, I have x. Let me make me a little table here. What is my next integer if my first one is x? It's x plus 1. What's my next one after that? It's x plus 1 plus 1, which is x plus 2. So if my first number is 10, my next one is what? 11, and then x plus 2, 10 plus 2 is 12. So 10, 11, 12. That's 3 in a row. So those are my 3 integers. So I'm trying to figure out what goes in here, okay? Those 3 blanks there. So how do I do that? Well, the sum x plus 1 plus x plus 2, and I could put it in parentheses to emphasize, but those are not necessary here, all right? And that equals what? Is what? 24. So equals 24. So I'm going to add all those up and say it's 24. So then we're going to put our like terms together here. X plus x plus x is 3x, and then plus 1 and plus 2 is plus 3 equals 24. We're going to subtract 3. We get 3x equals 21. Then we divide by 3 and we get what? 7. So x is 7. That's my first integer. What is x plus 1? 7 plus 1 is 8. What is 7 plus 2? 9. 7, 8, 9. That's 3 integers in a row. That's consecutive integers. So it meets that part. What's the other part it has to meet? They have to sum and be what? 24. What is 7 plus 8? 15. 15 plus 9? 24. Bingo. All right. So those are my, find the 3 integers, 7, 8, and 9. Boom. All right. There it is. 7, 8, and 9. Notice the next one. The sum of 4 consecutive what? Even integers is 212. What are the even integers? Now, you got to be careful because it says even here, and we're gonna have some even numbers, 2s in there, stuff, 4s, whatever. But if it's at odd, how far apart are odd numbers? Well, if you start with 1, what's the next odd number? 3. That's 2 away. What's the next odd number after 3? 5. That's still 2 away. So even though they're odd, you're still adding 2, which is even number. So it's the same deal here. 4 consecutive even integers. So we have x. We're going to start with x as the first one, okay? I'm being really original here with my variables, x. So then if the first one is x, what's the next one? X plus 2, right? Because if it's 2, it's got to be 2 plus 2 is 4. You can't do plus 1, 2, 3. 3 is not even. So 2, and then add 2 to stay even. Then what do you got to do for the next even number? Plus 4. And then finally what? Plus 6. That's going to give you 4. So if it starts with 2, 2, 4, 6, 8. Right? Those are your 4 consecutive even integers. The setup here would look the same way if these were odd. even though this is 2, 4, and 6. Students like to get confused and want to use 1, 3, and 5. No. If you start with an odd number, 3, how do you get to the next odd number? You still add 2. 3 plus 2 is 5. So you add 2, 4, 6 for consecutive, even, or odd integers. Okay? So here it says the sum of them is 212. So we're going to say x plus 2. And again, I could be using parentheses here, but they're not necessary on this one. Plus x plus 6 equals what? 212. It is 212, the sum of those 4. So then we're going to put these together. These 2 x's and that x is 4 x's. Then plus 2 and plus 4 is 6. Plus 6 more is plus 12. Equals 212. We're going to subtract 12. Well, that's nice. 4x equals what? 200. And then we divide by 4. I didn't give myself a lot of room here. All right. So what does x equal? Write it out here to the side. 200 divided by 4 is 50. So my first even integer is 50. The first thing you need to check when you get that answer is make sure it's even. If you get 49, either somebody messed up giving you the problem and you messed up working it, if it says even. Okay? Or the answer, there are no even integers that work this way. All right? I guess some teachers could do that. All right? My intention when I ask this is to give you one that works. Okay? That's my intention for my classes. So then 50, and then the next one is 52, and then what? 54, and then 56. So that's 4 consecutive even integers. What if you add them up? 50 and 50 is 100. The other two 50s is 200, and then 2 plus 4 is 6, plus 6 more is 12. Guess what? That works out. So what are my 4 even integers that are consecutive here? 50, 52, 54, and 56. So those are my 4 consecutive even integers that sum to 212. All right. A large city has a major toll bridge that costs $4 each time you cross the bridge. So some of you may live in metropolitan areas or large areas that have this. Every time my family goes to Orlando for Disney or for Universal or for SeaWorld or just for a trip, we go down the Florida Turnpike or something it's called, and we have to pay a toll. And so a lot of places do this. I think in Tuscaloosa, Alabama, there's one now that goes around the city, and it's a toll road, not a bridge. But if you ride on it, it's a kind of a bypass town, then you have to pay a toll, and they do that to help pay for it, okay, to help fund it. So here, this major city's built a big bridge and said, hey, you got to pay us $4 each time you cross it. We got to pay for this thing. The city sells monthly passes for $30. If you have a monthly pass and you're a member, you only pay $2.50 instead of $4 when you cross it. So what I want to know is, or what this wants to know is, what is the number of bridge crossings where the cost for crossing without a monthly pass is equal to the cost for crossing with a monthly pass? Now, that's a lot of words, and this kind of scenario, you guys, is very universal. When I first made this video, I called it the commons, and I said, well, I better just call it the basics and go with it. But I chose problems that are very common. It may not be a toll on a bridge. It may be something else. But this kind of problem where you have one rate here and then you have another rate with a fixed cost over here, and then you want to know where's the break-even point. Where do you break even if you buy the monthly pass? How many times do you have to cross the bridge? So if you go 3 times a month, every weekend except once a month across the bridge, I'll bet you're better off paying $4 a trip across the bridge. But if you work across the bridge and you go 5 days a week all month and go 20 times there, 20 times back, and you cross the bridge 40 times, oh, wait a minute, now maybe I need to be a monthly member, right? So let's see what this looks like. So if I don't pay the $30 fee, the number of bridge crossings, can we call that B? Call it B. We can call it BC for that matter, but call it B. So then $4 times that. If I cross it 50 times in a month and I'm not a member, I pay $4 times 50. I pay $200 to cross the bridge, period. There is no other fee associated with it. That's what I pay to cross it. That's going to equal, where do these two things equal? If I'm a monthly member, I pay how much money up front? $30, right? I pay $30. If I don't cross the bridge at all, I pay $30. And then how much do I pay every time I cross the bridge? Plus $2.50 times the number of bridge crossings, which is B. So $2.50 per. So now if I cross it 50 times, I paid the $30 up front, but all 50 times I paid $2.50 a time instead of $4. So we're just trying to figure out where is that break-even point. I have to cross the bridge at least what? At least 30 times to break even. So if I cross it less than 30 times in a month, I don't need to buy the membership or whatever the number is. We're about to find the number. So here I'm going to subtract 2.5 from both sides. 2.5b, that is. Okay, what is 4 minus 2.5? That's 1.5b equals 30. So then typically speaking, we get rid of our decimals when we're going to divide here. So I would move the decimal over 1, multiply both sides by 10, move the decimal over one place. So 15b equals 300. If I move it one place to the right over here, I got to do the same thing over here. Okay? So that's where I get my 15b equals 300. Divide by 15. And then b equals, look, 30 over 15 is 2, and you got a 0 on the end of it, right? So that's going to be 20. So your break-even point, if you go across it at least 20 times. So if you work across the bridge and you cross it 2 times a day, and you make roughly 40 trips a month, and then what if you go on the weekend to go shopping in town over that bridge in this large city? Or maybe it's a big city with a sports team, and you go, watch baseball games or football games or basketball games or hockey or whatever it is, soccer, anything. And you make more trips across the bridge. Now you're better off getting the monthly pass 20 times across. If you only cross it 4 or 5 times a month, you don't need to pay the $30, right? So that's what this is for. So how many? 20 bridge crossings. All right. How many bridge crossings? 20. Or what is the number that is the same? 20. So if you cross it exactly 20 times, you're going to pay the same amount whether you paid the monthly fee and were a member or not. And the reason you would want to know that is if you lived in this big city. I had some friends that lived in Chicago, and they have the little, I don't remember what it was called, but a bunch of toll roads, and they have this token you can hang in your windshield, and it's magnetic, and you can just go through the whatever lane if you have that token. And so they bought it because they lived there, and they worked in downtown Chicago, and so they were all the time running around, going places, doing things, and so for them it was well worth it. Okay, for them it was well worth it. All right, for us coming into town, we just paid the fees every time we went through one because we were there for like a week. All right, so after a 30% discount, you purchase a video game for $30.80. What was the price of the video game before the discount? Look, again, this is not really something you care about because if you go into the GameStop or wherever and you buy a video game for $30.80, you only care that it costs $30.80. You don't care what the original price was because that's not what you're paying. If you have whatever $30.80 is plus tax, you're buying it and you're done with it. So, but again, it's the idea of solving a problem. Okay, that's what this does. Word problems, applications, models, they're actually the most beneficial thing that an algebra student can do in algebra class. Did you just hear? They are the most beneficial thing an algebra student can do in class because you're taking a situation in the real world, maybe one you don't care about here, but you're taking a situation, you're applying math to it and solving a problem, okay? And that's what will help you in the real world because you're not, unless you're helping your kid later on with algebra, you're not going to graph a line or factor something or do something. You're going to solve a real world problem at work or at home that may require you to use some numbers or an equation or to think through something from problem to solution, okay? And that is where math helps you. That's why everybody has to take algebra. That's why it's a required course. It's not so that you can factor the rest of your life. That's the way a lot of math teachers think. And sorry, math teachers, if you're watching my video and you get mad at me, we're not that important, okay? That factoring is such a big deal for the person that's never going to see this again, right? It's going to be important when their kid is in ninth grade in Algebra 1 and they're trying to help them, all right? But by the end, they're going to have forgotten everything anyway, unless they use it, okay? All right, the things that you're going to do in life are going to be like this. Here's a scenario, solve the problem. It's not going to be a video game store, but I said video game and that caught some of your attention because there's a lot of gamers out there. Okay, my son's one of them. All right, I was one for a long time. I still like games. Actually, I'm old, but I still like games. Lots of games. All right, after a 30% discount, you purchase a video game for $30.80. So you have what was the price? So let's call it P for price. Wait, I just used that color. Let me try that. All right, so the P is the price. So we're going to say the price. Now 30%, if you change it to a number, you take 30%, you do what? Move the decimal place over 2 places, 0.30. And that trailing 0, you could just put 0.3 or you could put 0.30. So you have your price, and then you discount it minus 30% of the price. When you use the word of, that means multiply. So you apply a 30% discount. I took 30% of the original price as a discount. So you take P, the original price, we don't know what it is, minus 30% of the original price, 0.3P. All right? So that equals what? Well, the new price of the game after the discount is $30.80. Now, I have students all the time that say, Mr. Guest, this is good. I think this is good. Your teacher might not like this. I think this is great. I have students who will raise their, Mr. Guest, if I'm getting a 30% discount, that means I'm paying 70%. Glory, hallelujah, yes you are. Okay? That's awesome. 100% is all of it. So if you're getting a 30% discount, you're paying 70%. If you get a 20% discount, you're paying 80%. So they skip the step of P minus 0.3P and they put 0.7P because 70% is 0.70. And that's where we're headed here. See, the coefficient of P is 1. Well, what is 1 minus 0.30? Look, y'all think about money. What is $1 minus 30 cents? 70 cents. Aha. So this is really 0.70, that's a decimal, P, and that equals 30.80. Now, again, we don't like decimals here. Typically, we don't deal with those. So we're going to move these over twice. So if I move it twice to the right, I got to move it twice to the right over here. So 70P equals 3080. There's my new decimal. Divide both sides by 70. And actually, here we have an extra 0, but that's okay. So P equals, if I'm doing this in my head, I'm saying, I got an extra 0 there, so let me just do 7 into 308. So then 7 goes into 30 4 times with a 2, 28, that's 4. So this should be 44 exactly. I think that's 44 exactly. So here, this is going to be, what was the price of the video game before the discount? You don't care, but it was $44, okay? $44 was how much it cost before. But you got it for 30% off, so $30.80, all right? So this will give my age away, but a long time ago, when I would go to a store and they would have a sale, it would just have the original price on it, and it'd say 30% off. And you'd have to, in your head, figure out what that was. And then all of a sudden they start, all these department stores started coming up with these signs. If the original price is $17.99 and it's 25% off, the new price is, and it has, $17.99, $16.99, $15.99, $14.99, and then, discounted price, $12.99, $11.99, whatever, okay? And it has it all listed there for you, okay? You didn't have to do anything other than just look at, there it is, all right? So, but I promise there was a time, just ask your parents or grandparents, there was a time when we had to figure that up in our head when we went in the store. If it said 30% off, it just said $25 and 30% off. Well, that's $7.50 off. Okay. You had to do it. No, that's $17.50. It didn't say, 25 regular price, $17.50 sale price. It didn't do that. All right, so here, including a 7% sales tax, your total at the sporting goods store for your baseball equipment was $346.36. What was the cost of your equipment before the tax? All right. So figuring tax is a fundamental thing that you should be able to do, hopefully. So here I use 7%. That's what it currently is where I reside currently. When I was a kid, it was 5%. Now it's 7%. And the town I live in is actually 2 more cents on the dollar for food. I live in a university town, and so they go to 9% for food. So if you go spend $10 for something at a restaurant, it's going to be $10.90, not $10.70. Because they're going to get that extra 2% for that food. So including a 7% sales tax, your total at the sporting goods store for your baseball equipment was $346. And again, it could have been anything, but I chose baseball equipment. My son plays, and we're all the time having to buy him stuff. And sometimes it costs a lot. All right. So then here, the baseball equipment, let's see, what can we use for this? We're going to use Q for equipment this time. All right. So we're going to use Q for equipment this time. So let's go ahead and jump to a different color here. So baseball equipment is Q. So then the price plus, what is 7%? How do you do that? We'll move it 2 places. Here's your new decimal, and I got to add a 0. So that's the same thing as 0.07. So 0.07 times the Q, whatever the price was. So how much the stuff cost plus 0.07 times how much it costs. That's the sales tax. And that equals what? 346.36, right? So then if you add those together, this is a 1. Remember, 1 plus 0.07 is 1.07Q equals 346.36. Then again, we're going to move the decimal place 2 places. That's the same thing as multiplying by 100, by the way. So 107Q equals 34,636. And we divide both sides by 107. All right? If you need to go old school, go over there on the old school and write it down. We could even go over there and do that if you wanted to. But I'm going to just take my calculator out and punch it in my handy-dandy calculator. I'm going to say 34636 divided by 107, and I get 323.70, and it rounds at 0935. It keeps going, but money is 2 decimal places, so 323.70. So what was the price of all the equipment beforehand? $323.70. And if some of you that play baseball are like, what can you buy for that? Because it all costs more. I'm just kidding. All right. So definitely you can find some bats and things like that that really can get expensive and that kind of stuff. $323.70 is the price before the taxes. Now, if you wanted to figure out how much the taxes were, you could subtract the 2 or do the 0.07 times that number and get it. All right. So, but there it is, right? $20-something in tax, right? So let's look at the next one here. This is a classic problem in math where they say, hey, guess what? You have some money and you invested some of it at 5% and some of it at 7% annual interest, and you know you earned $570. How much did you invest in both accounts or in each account? So the deal here is this is simple interest, simple annual interest. Simple interest, not really around much anymore. I mean, it's usually some sort of compound interest, but just for the sake of solving a problem and using something, this is how we do it here. So what we're going to do, I like to build me a little table here and say, 5% and 7%. And then in the 5%, I have, I can do that interest down here. The total interest over here, the total, we have $10,000 total invested and we have $570 total. I build my table this way, which, by the way, if you look in a book for one of these, it's going to be done the other way because I'm breaking the whole dependent, independent variable rules or whatever it is they do. The reason I do this way is because my bottom row becomes my equation. Oh, that's nice. That's why I do it this way. So I'm going to put my, investment A and investment B, however you want to call it. Okay. So I have total of $10,000. So let's just say that I do X dollars at 5%, which, by the way, what is 5%? If we move it over 2 places, it is 0.05 and this is 0.07, right? We move it over 2 places. So if we do that, we have 0.05, 5% X. If I have $10,000, how much is invested at 7%? Well, guess what? It's 10,000 minus X. So if X is 1,000, then I have 9,000 in the other one, right? If X is 8,000, I have 2,000 in the other one. They have to add up to 10,000. So one of them is X, and this is where we call the other, instead of calling this Y, we know the total, do the total minus this much to get this. And that's how we got that. So 10,000 minus X, and then X for one, and then 10,000 minus X for the other. Then to get the bottom row here, we multiply these together. So 0.05X. And then 0.07 times 10,000 minus X. And it says the total interest, we're going to add them, the sum. So here's my equation right here. 0.05X, we're going to add it to 0.07 times 10,000 minus X, in parentheses, equals 570. That's my equation that I'm using here. So I'm going to take this equation, I'm going to distribute the 0.07 here, and I'm going to bring this equation up here in some space I have. I have 0.05x plus, move that 2 plus 700 minus 0.07x equals 570, right? So 0.07 times negative x is negative 0.07x. I'm going to put these together. 0.05 minus 0.07 is negative 0.02x. I'm going to go ahead and move this over. I mean, look, there's nothing else to do with that 700. Go ahead and move it over. So 570 minus 700 is negative. Hang on. Make sure I clearly a negative 130. Then we're going to divide. Oh, wait a minute. We're not going to divide yet because it's a decimal. I'm going to move it 2 places. Move this 2 places. Right here was the decimal, so I'll move it 2. So I have negative 2x equals negative 13,000. Divide by negative 2, and a negative over a negative is what? Positive, and 13,000 divided by 2 is 6,500. So my x is 6,500. This is 6,500. So then this is going to be 10,000 minus 6,500, which is what? 3,500. So I didn't put it on here with blanks like I would on a test, but typically I'll have X number of dollars at what percent and X number of dollars at whatever. So here it is important. You can't just say 6,500 and 3,500. You got to tell me 6,500 at what percent. So, or your teacher, whoever. So $6,500. Hang on. Let me fix that. That's pretty ugly. $6,500 at what? 5%. And what? $3,500 at what percent? 7%. So those are my two amounts and the percentages that correspond with them. You can't say 6,500 at 7% and 3,500 at 5%. That won't match up right. So the $6,500 is at 5%, and what you can do is you can multiply 6,500 times 0.05, 3,500 times 0.07, and then add those up, and they should be $570. Okay? So, but it's important there, the amount at the interest rate. That's important. Okay? Most likely that's how you'll have to answer it there. That's how all the books that I've seen over my many decades of teaching and tutoring have done. All right, again, my brother put a pool in his house a couple of years ago, and he didn't have to do all this, but I'm just saying, a pool. This could be, there's a problem in the book I use right now, a football field. In the past, on tests that I've given, I've done soccer field, I've done football field, I've done ultimate frisbee field because I love ultimate frisbee. I'm getting too old to play it, can't really run around anymore, but I love to throw a frisbee, and so my kids love to play it. So the length of a rectangular pool is 6 meters less than, there's that word, than turns it around, twice the width. If the pool's perimeter is 126 meters, what are its dimensions? So what we're trying to do is we're trying to find something by something, okay? And it's meters here. That's our unit is meters. So really, we could go ahead and say, hey, guess what? We know we're going to have so many meters by so many meters. And I don't get caught up in length and width and which one is which and all that. As long as you give me the two numbers, I don't care if one, if it's 10 by 12, I don't care if you do 10 by 12 or 12 by 10. All right, I don't. Your teacher may say, hey, you need to do this way or whatever. So, but look, the length of a rectangular pool, the length is, I don't use a lowercase L. That looks like a 1 for most everybody that writes it. If I use a lower L, I do it cursive. Otherwise, I do a capital L. Okay? I want to encourage you when you do these to think about when you write something. If you write the letter S, cap the ends, and I'll tell you what I mean by capping the ends of an S, is going to be this right here. Cap the ends, okay? Versus a 5. My 5s and S's look a lot alike. So I try to be very proper and precise when I write them so you can just tell the difference, or I can tell the difference when I'm working something. I have students all the time that turn Z's into 2's in the middle of a problem. When I write a Z, here's my 2, here's my Z. My Z has a line through it, Z, okay? So again, let me just say that. So capital L here or cursive L, don't use just a straight up down line because you'll think it's a 1. So L, the length is 6 meters and then less than. Instead of doing 6 minus, it's minus 6. Remember, the word than turns it around. 6 less than what? Twice the width. Uh-oh. Let's see. We're going to call this L, so we got to call this W. All right, so 2W. Now, here we go. We got 2 variables, but that's okay. We have some more information. The perimeter is what? 126 meters. So the perimeter is 120. I'm not going to worry about the units. I wrote my M's down already for meters. My perimeter is 126 meters. Well, what's the perimeter of a rectangle? It's 2 times length plus 2 times width, is it not? Well, guess what? I know some things. Here. Watch this. I know that 126 goes in for P, and I know that all of this goes in for L, right? So then what I'm going to do here is I'm going to write 126, and I'm going to bear with me as I change colors, equals 2 times L plus 2W. Well, wait a minute. What was L? L was 2W minus 6. So notice what I've done. I replaced my P with what I knew it was, 126. I replaced my L with 2W minus 6. I don't know what it is, but I put it in terms of W. And that's nice because now, what does this blue and gray equation have? It only has W in it. No other variable. Just W. Now I can solve it. Okay? So let's look here. We got 126 equals 4W minus 12 plus 2W. And then we're going to put the W's together. I'm also going to go ahead and add my 12 because, I don't need to do anything else with that 12. So get rid of it. This is 138 equals 6W. Divide by 6. And I believe that is Michael Jordan. Oh, I'm sorry. That's 23. All right? So I know all you young people might think LeBron or somebody's the best, but nobody was ever better than Jordan. So grew up watching him play, and he was just better. He just there was something different. All right, so 23, and I officially have renamed that MJ, Michael Jordan. So anyway, no, 23. The width is 23. So guess what? I already know one of my answers is 23, and I don't care which one you put it in for me. All right, 23 meters by what? Well, how do I find L? Well, guess what? I know that L is 2 times the width minus 6. But wait a minute, we know what the width is. It's what? 23, so this is 46 minus 6 for L. So then L is what? 40. So then 23 meters by 40 meters. Okay? So we had to get the relationship right between L and W. L is 2W minus 6. I think I've done like 3 times it plus 11 or something. Or 4 times it minus 7. Or 5 times it plus 1. Okay? Or just twice the length. So just 2 times it. Okay. Or 3 times the length. Okay, 3 times it. No plus or minus anything. So you got to get that relationship L and W, one in terms of the other. Then you know your perimeter. And you got to know what a perimeter, you know what a rectangle looks like. 2 lengths and 2 widths when you add it up for the perimeter. That's adding up the sides. Then you can go through and work it. Once you find L or W, then you plug it back into the, relationship between L and W equation, and you get it. All right? So then this again is another just kind of standard problem that's out there. I made it more fun because one day I want to own a side-by-side. Maybe I will arrive and have me some sort of, side-by-side vehicle or whatever. My son just got a go-kart, and I still ride it even though I'm way too big for it. But it's so much fun. A repair bill on your side-by-side came to $1,603. That includes $532 for parts and the remainders for labor. All right? If the cost of labor is $63 per hour, how many hours of labor? So we read it. We're going to go back and go over it. Look, I've seen this with rental cars on a per-day fee plus the number of miles, because back in the day, when you went to Enterprise Rent-A-Car, you paid $25 a day plus 10 cents a mile. Some of y'all are like, what? I thought it was just unlimited mileage for $30 a day. It is. It is now. Almost all of them are unlimited mileage now for that. But back in the day when you rented a car, you paid $20 a day plus 7 cents a mile or whatever it was. And they read the odometer and you brought it back and read it again and all this other stuff. All right. This could be, my dad has a business. This could be his fixed cost. You know how much his monthly electric bill is and all this other stuff. And then plus some kind of variable where it's how many hours each person works, right? So the number of people that work times the number of hours they work times the pay rate, right? That changes from month to month depending on what goes on there, okay? So there's all kind of applications to something like this. Again, this is just a scenario. It could be your boat, your side-by-side, your ATV, your car, whatever. So here, how many hours of labor? All right. Now I'm guessing if it was $500 for parts and $1,600 total dollars, it might have been a lot of labor in this. This was a labor-intensive project. All right. So let's look at this. The repair bill came to $1,603. That's the total. So $1,603 equals what? Well, your parts are $532. You only pay for the parts once, you hope. Okay? But you have to add to the parts what? Labor. So $63 per hour. So what I'm going to do is call it capital H for hours of labor. You call it L, but we've already used L, so let's use H. So plus, it's $63 times H, right? Of labor. How many hours of, when you have the of, typically, something of this, you multiply there. So it's multiplied, 63 times H. There's our equation. So $63 per hour times the number of hours, that gives us dollars, plus the $532 fixed cost equals the total bill for this thing. And then we're disregarding tax here. We're being simple with it. All right. So what I do first is subtract my 532. And then it's going to be 63H over here. And 1603 minus 532 is 1,000. Is that 71? So let me just make sure before I move on that I didn't goof that up too bad. 1603 minus 532 is 1,071. Then we're going to divide by 63. And look, 630 is 10, and it's not 1,200. So, and then 3 into 1 is going to be a 7. So I'm saying that's 17. All right, but I can divide it by 63, and it should be 17. It is 17. So 17 equals H. But again, H equals 17 is not the answer. The answer is how many hours of labor. So it's 17 hours. Now, if all they did was change my battery out, they're jipping me off, right? But if they had to take the front end off and realign something and put a new axle or what, I don't know what you would do to it, but what may have to happen to it. So maybe it did take 17 hours. Okay, so 17 hours is the proper answer there. And again, all of these things that I did, the scenario problems have other scenarios you could have done. Okay, so I've seen boiling water where you're taking away something. Talking about the discount, or you're adding something to a solution in chemistry where you're adding to it, sort of like sales tax. So it may not be a tax issue, but it's the same type of deal, even though it's a chemistry lab or something. So, or you're boiling water away, cooking something or whatever. So here is these are the word problems, the applications, the models. I hope this helps some. Again, these are just some basic scenarios. You may or may not have all of these in your class. I don't go over every one of these and every time I teach it. I do some of these and sometimes I do others and that kind of thing. So, but hopefully this video will help you with those things.